Alright, so in this problem, I have 9 to the power of 900 minus 9 to the power of 901. So, for my solution, I'm going to first start by rewriting my original problem here. So I rewrite 9 to the power of 900 minus 9 to the power of 901. And now this is the same thing as, can rewrite 901 as 900 plus 1. So this is the same thing as 9 to the power of 900 minus 9 to the power of 900 plus 1. Now, there is an important exponential property that you guys should know. So if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, we have 9 to the power of 900 plus 1, and using this property, we can rewrite it as 9 to the power of 900 times 9 to the power of 9 to the power of 1. Now from here, notice how we have two terms here. Our first term is 9 to the power of 900, and our second term is 9 to the power of 900 times 9 to the power of 1. So because both of our terms have 9 to the power of 900 in them, we can factor that out. So we can factor our 9 to the power of 900, and we get 9 to the power of 900 times, 9 to the power of 900 divided by 9 to the power of 900 is 1, minus 9 to the power of 900 times 9 to the power of 1 divided by 9 to the power of 900 is simply just 9 to the power of 1. So I get 9 to the power of 900 times 1 minus 9 to the power of 1. And 9 to the power of 1 is the same thing as 9, so I get 9 to the power of 900 times 1 minus 9. Now from here, I'm going to simplify what's in my parentheses here. 1 minus 9 is negative 8, so I have 9 to the power of 900 times negative 8. And I can rewrite negative 8 as 8 times negative 1. And now I'm going to multiply negative 1 with 9 to the power of 900. So I get negative 9 to the power of 900 times 8. Now from here, I can rewrite my 9 here as 3 squared. So I get 3 squared to the power of 900 times 8. And now 8, I can rewrite as 2 to the power of 3. So I have negative 3 squared to the power of 900 times 2 to the power of 3. And now remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this can equal negative 3 to the power of 2 times 900. And now I have this times 2 to the power of 3. And if you guys already didn't know, 2 times 900 is 1800. So I have negative 3 to the power of 1800 times 2 to the power of 3. So this is our answer in its most simplified form. We can't, if you want, you can try putting in 3 to the power of 1800, but that number is way too big for any calculator to actually be able to output. So this is the simplest form that we can put our answer in. So that is our answer to 9 to the power of 900 minus 9 to the power of 901, and see how much big of a difference it is. Alright, so in this problem, I have a to the power of 3 plus a squared is equal to 80. So to solve this, I'm going to first start by subtracting 80 on both sides. So I get a to the power of 3 plus a squared minus 80 is equal to 0. Now I'm going to rewrite this as a to the power of 3 plus a squared minus 64 minus 16 is equal to 0. So I simply wrote negative 80 as negative 64 minus 16. And now, negative 64, I'm going to rewrite that as negative 4 to the power of 3. So I have a to the power of 3 minus 4 to the power of 3 plus a squared minus 16, I'm going to rewrite as 4 squared. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is going to equal a minus b times a squared plus ab plus b squared. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, if by using these two properties, I'm going to end up with a minus 4 times a squared plus 4a plus 16 plus a plus 4 is equal to 0. And this simplifies to a minus 4 times a squared plus 5a plus 20 is equal to 0. So now this gives me two equations. I get a minus 4 is equal to 0, and a squared plus 5a plus 20 is equal to 0. So for a minus 4 equals 0, a is obviously equal to 4. And for a squared plus 5a plus 20 equals 0, I'm going to use the quadratic formula, but I'm actually not going to waste your guys' time by actually doing it. So if you do end up doing it, you get that a is equal to negative 5 plus or minus the square root of 55i over 2. And the reason, actually what you should get is a equals negative 5 plus or minus the square root of negative 55 over 2. And the square root of negative 55, I can rewrite that as the square root of 55 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So if I replace I with the square root of negative 1, I get a is equal to negative 5 plus or minus the square root of 55 I over 2. So that's how I got square root of 55i. Alright, so in this problem, we have the square root of 3 to the power of x is equal to 81. Now, to solve this, I'm going to start here with the square root of 3. So let's just ignore everything else for a second and focus on the square root of 3. Now, the square root of a number is, say the square root of x. This is the same thing as x to the power of 1/2. Because basically, the root here is 2, but we just don't write that. And the cube root of a number, that's that number to the power of 1 over 3, because we have a 3 over here. So the square root of 3, we can think of 3 as x in this case, and we can rewrite this as 3 to the power of 1/2. So now, if I substitute in 3 to the power of 1/2 for square root of 3, I get 3 to the power of 1/2 to the power of x is equal to 81. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 1/2 to the power of x, that's going to equal 3 to the power of 1/2 times x, which is simply 1/2 x. And this is equal to 81. Now, 81, that's the same thing as 3 to the power of 4. So now I have 3 to the power of 1/2 x is equal to 3 to the power of 4, and this means 1/2 x is equal to 4, and x is equal to 8. So 8 is my answer. Alright, so in this problem, I have 2 to the power of 20 minus 2 to the power of 19 is equal to 16 to the power of x. So I'm going to first start by rewriting 20 as 19 plus 1. So now I have 2 to the power of 19 plus 1 minus 2 to the power of 19 is equal to 16 to the power of x. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 2 to the power of 19 plus 1, and this is going to equal 2 to the power of 19 times 2 to the power of 1. Now I have this minus 2 to the power of 19 is equal to 16 to the power of x. Now from here, if I factor out 2 to the power of 19 from my left-hand side, I get 2 to the power of 19 times 2 to the power of 1 minus 1 is equal to 16 to the power of x. And 2 to the power of 1 minus 1, that's simply equal to 1. And anything times 1 is itself. So I have 2 to the power of 19 is equal to 16 to the power of x. Now, 16, that's the same thing as 2 to the power of 4. So now I have 2 to the power of 19 is equal to 2 to the power of 4 to the power of x. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 4 to the power of x, that's going to equal 2 to the power of 4 times x, which is also 2 to the power of 4x. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 19 is equal to 4x. Now we have a simple equation here. All I have to do is divide both sides by 4, and I get x is equal to 19 over 4. Now, to check, my original equation was 2 to the power of 20 minus 2 to the power of 19 is equal to 16 to the power of x. Now, 2 to the power of 20 minus 2 to the power of 19, we already know that's 2 to the power of 19. So we get 2 to the power of 19 is equal to 16 to the power of 19 over 4. Now 16, that's the same thing as 2 to the power of 4, so now I have 2 to the power of 4 to the power of 19 over 4, and these two 4's cancel out, so I get 2 to the power of 19 is equal to 2 to the power of 19.